Okay, this is a video I'm going to make on an example of an application of how we can solve a matrix. I know we did this one in class, but I just want to make a video of it so you can go back to it on your own and take a look, because this one example covers a lot of things: how to solve a matrix, how to set it up using labels so we know how to organize the data, and how to transpose a matrix. So it kind of covers all those things in one example. So that's why I want to make a video of it. Notice the first thing I did was I put all the data into my calculator. So look at the calculator on the right, and notice the data matches exactly of what how it's given to me. So just the raw data, I went ahead and entered it. I also entered the 500 calories, 3 grams of fat, and 100 grams of carbohydrates in the calculator as well. But now I'm going to show you how to set it up. I'm not going to set it up using systems. I'm going to go right to matrix setup to show you how we can set it up using labels to organize our algebra. Here we go. So first I'm going to start with just the plain old matrix brackets to get everything organized. I'm going to make that just a little bit bigger so I have some room to write. Okay. So there's the A matrix, and then we have the X matrix equals, and then last the B matrix. Okay. Now I'm going to work backwards on this. And notice the numbers I want over here are 500 grams, or I'm sorry, 500 calories. And then I want the 3 grams of fat, and then the 100 grams of carbohydrates. So over here, this label is nutrition. Okay? I'm just going to abbreviate. And what we have here for the label of the column is the amount of. So I'm going to use those two labels to dictate how we set up the problem to the left-hand side. What we know is this column label comes from that column. Just like if we have in this case, a 3 by 3 matrix, and it's going to cancel out with a 3 by 1 matrix, we know that those two labels have to cancel each other out. And then this ends up being the answer here, and this ends up being the answer here, so we have our rows times column as your answer. Well, just with numbers, the same thing works with labels. So what we have here is amount comes from this column, and the nutrition is the row title here, so I'm going to put nutrition over here. And I'm going to label it calories, fat, and carbohydrates. So that tells us that that has to dictate the row in order for this answer of 500, 3, and 100 has to exist. So what we're going to do is figure out, okay, what's our other label here? Well, the only thing we haven't talked about is the type of cereal. So I'm going to put cereal here and cereal here. And notice we have 3 different types. We have the bran crunchies, the toasted oats, and the whole wheat flakes. And I'm going to have the same thing here. By having it this way, this label and this label are going to cancel out just like it canceled out up here. And what's left is the nutrition, which ends up becoming the row over there, and then the amount becomes the column heading for the answer. So now that our labels are set up, now we can go back in and fill in the data. So over here, I'm going to give variables for our X matrix, obviously. So I'm just going to use BTW for the amount of each cereal type. And over here, notice something that's different. Notice my data. I'm going to erase this out of the way so I have some room to write. Notice up here we have cereal as a column heading on our matrix. But over here, cereal is our row heading. So we have to flip the data. This is called transposing. So instead of taking this data and writing as a column, I'm going to write it as a row, because it matches. This is the calories of each type of cereal, and this is the calories of each type of cereal, both top and bottom. So I had to transpose it and flip the rows and columns. So now I'm going to put this data in throughout so it matches the headings. Now, obviously, if you have not put your data into your calculator, you could enter it in just like this here, and we could type in A times X is equal to B, and do our A inverse on both sides, and get x is equal to A inverse B. But now I'm going to show you a trick and how do we take care of A if we've already entered it into our calculator. So I'm going to pull up my calculator once again and scroll up a little bit, turn it back on, and I already have my data entered in. And I don't want to re-enter it so it matches this matrix here. The calculator can do it for me, and it's called transposing, and this is what you do. You go to second matrix, pull up matrix A, second matrix again, scroll over to math, second option is that little t. It's like an exponent of t. That means transpose. So I'm going to take this data of matrix A, transpose it, and flip it, and notice what was once a column is now a row. So the calculator can do all that work for you. So instead of me retyping the data, watch how I tell the calculator how to flip it for me. So instead of A inverse B, I'm going to type in A transpose, and then I'm going to take the inverse of that. So it's telling me to take the transpose of A and then inverse the whole thing. And now I'm going to multiply it by B. And that should yield my answers. And notice, here's my answers right here. So what does this data mean here? I'm going to scroll down here and show you how we answer the question now. So I believe our numbers were 2.3, 0.8, and 1.2. I'm just going to pull it back up to make sure I'm somewhat correct. And it looks pretty good. So these are the answers to the matrix of BTW. And again, we want to put a label on this. So that's this raw data, and this is the amount in ounces of the types of cereal. So that way I know what this data means. And again, this is the bran, the toasted oats, and the whole wheat. So this is a good example of how to set these problems up. We have raw data, set up the matrix with the labels first, put in the data, and figure out, do I have to transpose it? Do I have it in the right order? Again, the same A inverse B operation, and we're able to yield the same answers. And this process can be applied to a lot of other problems with the same type of setup. Okay, so just keep this in your notes. Need to look back at it. Great example.